Hi, folks. So my goal is to see how many of you guys I can keep awake being the last session and more importantly, keep you here rather than going by the pool and having a beer. And I'm already losing that battle. A bunch of people walked out. So I work for Cisco. I spend most of my career doing identity stuff. The last 9 months, I actually sort of moved to the security group, and it's been eye-opening. Hopefully, some of the lessons I learned and some of the things I'm going to share with, it's a little bit different view on looking at identity and on IoT, and especially I'm looking at a little bit different aspect of IoT. As you've seen with all the different conversations around IoT, it covers everything in kitchen sink. So everybody has a different view based on their products, their technology, which sliver of it they're looking at. And mine is a little bit more of a industrial IoT flavor into it. So when we talk about IoT, these are typically things that comes to mind. That's what we see every day. This is typically sort of around the consumer, and its model is it's somewhat different. There are a lot of common things between this and this, but there are a lot of differences in it as well. And this is what sort of, I spend a few months working directly and indirectly with a few different proof of concept ideas with some of our customers and some of our partners. And while I'm not going to talk about any of those specific POCs, but there are trends that came through sort of seeing and working with these projects that hopefully kind of, bring in some new ideas. So why do we care about this? I think GE was the first company that actually came up with the power of 1% rule. Huge amount of money is in this thing. If they basically did a lot of research in different verticals that they're in, that if you sort of improve efficiency of the infrastructure in that vertical by 1%, how much money you could gain over a span of time. So in 15 years, in the, oh my God, my eyes are so bad. The oil industry, you could save sort of, 60 or is it 90 billion? $90 billion over 15 years. So there's a lot of money to be made, which is why everybody is trying to sort of associate themselves with IoT and get into that part of the picture. So what stops us from actually moving forward? Guess what? Security and identity is kind of part of that. Every one of the sort of, deployments, every one of the polls, every one of the conversations really center around security, especially when you sort of, when we get past the light bulb or sort of the very basic infrastructure, when we talk about safety being part of it, when we talk about connected vehicles, when we talk about factories and more of the industrial applications of it, security obviously becomes much bigger play. And when you have $90 billion at stakes, guess what? The privacy and access to the data could be a huge part of the challenge. So when we talk about IoT security, what are we talking about? Number one is trustworthiness. It's not necessarily just the basic identity notions or authentication or authorization. It goes way beyond that. Can I trust the data that I'm getting from this thing that's coming sort of, reporting some information to me? Has it been tampered with? Has it been cloned? And is this really the one that sort of, I provision and I want to be talking to? So there's a whole bunch of things around trustworthiness that's generally, for a lot of us in the identity space, is new, and we don't really think about it much. We sort of think about a user, some sort of authentication, some protocol for sort of, exchanging authentication and authorization tokens and whatnot, and we're sort of done with it. But this goes way beyond that. The other thing that's really different in a lot of these contexts is the identity and the fact that the device identity might not be as important as we usually think about it. And it's much more important that sort of, the identity, the context that's around that identity. And then I'll talk about that a little bit later. Another aspect of it, which is huge, provisioning and the lifecycle management of those devices. I mean, we were just talking about PKI and key management. Well, that's great in a whole bunch of applications, and he solves a lot of problems, but what does it mean when I put a new part in my car? How am I going to manage the keys if everything is based on sort of, crypto, and it's not sort of, how do we manage the life cycle of it? How do I sort of rotate these things? How do I manage it through a very long life cycle, especially around industrial things where life of a thing might be in decades, not in months or weeks or a couple of years. Obviously, authorization and access is a huge part of it. It's sort of, that's what we're the experts, that's what we sort of, make our living. And then there's a lot of legacy. There are factories out there. There are oil rigs out there. There are trains sort of, running today. And we have to sort of connect the modern world of looking at things and the sort of the IoT view of the world into the old sort of, style. Everybody's car has a very, very unprotected bus called CAN bus. Now, we're putting entertainment systems in the car that are fully connected, Android-based or sort of Linux-based or whatnot, and it's connected to the world, and it is connected to the CAN bus as well. What does this mean to the safety, to the security of the system if the media or entertainment system is compromised? If you look at sort of, and there's a whole bunch more of these things, sort of, hopefully these are just samples and certainly not an exhaustive list. If you really look at these things, what really sort of, is going to be common across a lot of these things, in order to get a lot of these things right, we need to do identity. And that's where sort of, a lot of people that are in this conference really sort of, play a role into this space. So let's take a look at sort of, the consumer space of sort of identity and the trust anchor. So I go to Home Depot, buy myself a Nest. Guess what do I do next? I go create myself a new username and a password on the Nest website. And I'm not picking on Nest in any ways. This is sort of, true for Fitbit. It's true for pretty much anything that you buy on the consumer side. You go get yourself an account on their site. And if I want to buy another thing, if I want to develop something that actually integrates with it. So let's say I want to sort of have a fan that actually sort of, integrates with it. Well, the only way that it works is if I integrate using sort of, Nest authentication server, if I use Nest API model, if I use Nest authorization server. That's the only way I can actually connect my thing to it. To be honest, this doesn't really seem standard-based to me. This is sort of, I don't want to say it, but it's forced. I'm being forced to sort of, play in that platform. Somebody got that one. What about this? In this model, can we do that? I mean, it doesn't matter how big, how pervasive your products are, even for a company as big as Cisco. Oh, by the way, I forgot. Disclaimer, these are all points of view that are mine and not representing Cisco. This is not sort of our partners, our products, our technologies. This is completely Morteza's talk, so I forgot to say that up front. But in this world, it doesn't matter how big you are. The infrastructure, the ecosystem is much, much larger than one vendor, one solution. I cannot put up and say, you have to create an account in my infrastructure if you want to be in my factory. That just doesn't work. So let's do a little bit of a double click on this. So let's just pick an example. I'm building a new sort of, factory, and I need a robot arm that sort of, moves some sort of object or moves some sort of a tooling to build something. I need a spot welder to weld some parts of that sort of, object that I'm working on. And sort of, I have a conveyor belt or sort of a smart dolly or whatever that can actually move the tooling or sort of, the part around on the factory floor. Each one of these things are built by a different manufacturer. So there's a company that makes the robot arm. There's a company that makes the next piece and the next piece and the next piece. Well, I don't actually go and build this. So the next thing is it goes into a system. I wish that was a better color. It goes into the system integrator that sort of, takes these different components, programs them, weld them, kind of bolt them on together, and make up sort of the system that actually produces that part that I'm interested in making it. I go buy that, and I sort of, put it in my factory, deploy it. In quite actually a lot of, I was really surprised at the next step. In a lot of cases, there's actually a separate entity that's doing the operations of it, not necessarily me as the owner of the manufacturing floor, but somebody else might be playing a role in there. As you can see, this is getting sort of a lot more complex than the Nest thermostat that I was going to sort of, I bought and I plugged into my wall and sort of, and I sort of managed myself an account. So if you take this and abstract it a little bit more, we got one or more sort of OEM vendors that building this sort of initial parts. We've got system integrators that sort of, bring them together to kind of, make a cohesive story around that automation, that process. We got the owner that sort of actually is owning this infrastructure. We got operators that are playing, and certainly you always have the app that really is hooking up everything, doing the data analysis, doing the sort of controls and whatnot. Real life is a little bit more complicated. You actually have many apps, you have many of these system integrators, and you have potentially many of those sort of, operators. And guess what? All of these people have their own employees, have their own staff, have their own sort of, devices or things that need to talk to each other. Well, guess what? They all have their own sources of identity that you have to deal with. But hey, we know this. We've already been doing federation, so we can build federation between sort of, the owner and the system integrator. We can build the next federation, and the next federation, and the next federation, and the next, and the next, and the next. Well, we sort of gotten this one figured out too. We have sort of, built multi-point federations, but this is when we start pulling our hair and sort of, going nuts, because this is not easy. I mean, yes, we've done a couple of cases of like this in the industry, but generally speaking, this is not easy. If you want to repeat this over and over and over at every factory, at every oil rig, this is going to be a big problem. So that's authentication. That's the easy part because we actually sort of done a pretty good job of solving the authentication problem. What about authorization? We got the technician that works for the robot arm manufacturer. Thank you. Robot arm manufacturer that basically wants to sort of, do some things to that robot arm because it's part of their service contract, it's part of their regular maintenance, whatnot. Potentially it wants to sort of, read the diagnostic data from the robot. Is the robot vibrating too much? Is the temperature too high? Is it sort of, within sort of the normal sort of operating limits? Maybe if it sees something wrong, it might want to sort of run some diagnostic routines. That's absolutely good. That's exactly what we were trying to enable. But we don't want to allow that technician to actually read the movement of the robot because it could be trade secrets on how this robot is drilling the holes in a specific part that manufacturer wants to keep it to itself. So we need to make sure that we protect that action. We certainly don't want the technician to be able to sort of move the robot around and cause all sort of damage or other problems in the production line. Maybe under certain circumstances or conditions, we want to sort of allow that technician to upgrade the firmware, put new sort of, tests, put sort of, newer capabilities into the robot. And again, that needs to be authorized. Well, we sort of know how to do this. I mean, generally speaking, our authorization in the industry is a lot farther behind than authentication, but we sort of can do these type of things, right? What about when you have a factory floor and dozens of these things? Multiply that by 10, multiply it by 100. What are you going to do now? And it's not always the technician that's doing this. It's going to be the device that talks to the device. It's going to be the other vendor that talks to this. It's going to be the system integrator. It's going to be the application. And when you sort of start looking at that authorization model, going with the technologies and the way we do things, it's going to result in all sort of really, really interesting scenarios. Everybody depressed now? One more time. All right, so let's look at the sort of the device identity. I talked about it a little bit earlier. Traditionally, we've always been really, really sort of, thinking of as this device identity as I can sort of, uniquely identify this device. I can give it a name. I can give it a maybe globally unique or maybe within that sort of that domain a unique name, so I can identify it. I can know exactly which sort of, temperature sensor this is. But in real sort of, in the IoT world, in a lot of cases, that actually is not necessarily the problem. What I care about is this a sensor that's deployed in this room? Not necessarily which serial number, when was it manufactured? Like all those things might be interesting, but are not really sort of the big drivers. Is it trustworthy? Can I trust the data that's coming from it? Because I want to act, I want to turn on the air conditioning, I want to sort of, flood the pipelines with sort of water coolant for the nuclear reactor because of that temperature reading. So I want to be sure that I can actually trust the value that's coming from it. Is it somebody that sort of cloned it and sort of, put a different one on the network? So these are the things. When you look at sort of various things, I want to know the calibration information about the device. When was it calibrated? Is it healthy? What kind of network is it on? Is it on a wireless network or is it on a wired network that I can sort of have additional trust? That context is what we really care about in a lot of cases as opposed to the absolute identity of that device. And that's one of the things that we really need to sort of, look at it differently. And there's a whole bunch of other these parameters that would be interesting in a real industrial case. Even in sort of home examples or the consumer side, there's a whole bunch of these things that could play a role. And generally, this is an area that we're really not good at. We've done sort of slivers of it in the industry in specific areas, but we haven't really come up with a good solution that can solve the sort of the broader sort of set of cases for this. Other challenges, I mentioned sort of, bridging legacy and modern. That's a repeat sort of, story. Every conversations I've had, sort of, you end up with some of this. There's a huge number of very insecure protocols, very, very basic communication mechanisms between devices that we're sort of, taking the next step and exposing them to a different world. There's a whole bunch of challenges that are associated with how do you do that bridging. How do you sort of, connect the CAN bus into your media control unit in your car without sort of, completely being owned and somebody sort of disabling your steering or your brakes or blow up your engine past the red line when sort of, somebody owns your entertainment system, which I don't really care about it as much. And there's a whole bunch of work that needs to be done in that space. And there's a lot of it actually is being done, but certainly more work is needed on that. The other one, I mean, Hannes talked about this quite a bit. Not all devices are created equal. Some devices have practically unlimited computing capabilities. Some of them have almost none. They have no battery, you can't just sort of, come up with a PKI will solve our problems or this will solve our problem. We have to have a sort of a whole different set of capabilities for managing this infrastructure given those devices. Another one that's really new to us is the life expectancy. The locomotive diesel engines that were put on the tracks in 1950s are still operating. Yes, they get maintained every once in a while and rebuilt or sort of, touched up, but they're still running today. That's 50-year, 60, 70-year lifespan. That's very different than when we sort of built some technology in the software world and sort of, like 2 years later, it's obsolete and we don't even think about it. 5 years later, it's history. Nobody even remembers what it was like. So that really changes it. And then the other piece that Hannes also mentioned, touched on, is the crypto life is actually about 20 years. So crypto technologies that we were proud of 20, 30 years ago are the ones that we absolutely laugh at and we would not allow anywhere to be used. What if the sort of the technologies that we're building have a lifespan of, on the industrial side, of 50 years, but the crypto has 20 years lifespan? What are you going to do with that? And then I'm just going to skip over the next one, but the other problem with that is access. Most of these things, they don't have people that actually understand computers. If there are staff there, this is the IT versus OT conversation that Daniel talked about this morning. If there's staff there, at best, the places that you actually have a lot of sort of computer knowledge, they can sort of unscrew a machine from the rack, put a new one in its place, and plug it in. There is no keyboard. They're wearing sort of an inch-thick gloves. They can't sort of touch on keyboards. Touch screens are useless. A lot of these things that we take for granted on a day-to-day basis and in the general identity space, especially around consumer, is really not applicable when it comes into the industrial stuff. Some of these devices are deployed in oil rigs in Alaska or sort of very remote places. It costs a lot to actually get to them and maintain them or touch them if you really need to do that. Connectivity to these sites are not reliable. They don't all have fiber going to them. Some of them are sort of, they're very weak radios, very expensive to sort of transfer data through them. And in a lot of cases, they're very unreliable. And sort of, I'm certainly not going to talk about that aspect of it, but the failure scenarios are absolutely complex and it could be sort of life-threatening. If you sort of, disable or some piece of the system fails, what is the impact of it on the rest of the infrastructure and how does it really affect the overall system as a whole? And then privacy. I mean, Steve was talking about this. I found this and I had to sort of include it in there. The reality is, even if it's not sort of the consumer privacy aspects of it, the data privacy. When GE makes jet engines and sells them to Boeing and Airbus, which are fierce competitors, and then Boeing and Airbus sell their planes to Delta Airline and United Airline and American Airline, every bit of information that GE collects on those engines needs to be considered. Is this going to be a sort of a trade secret that I'm sort of giving away if I start sort of, acting on it? So there's a lot of complex things that goes around that privacy. That's not necessarily my personal privacy, though that's a huge thing, and I'm not sort of, taking any of that away. But it's taking a different world, and it's a lot of dollars associated with it. Okay, so now what? So as I mentioned, I've been involved with a few of these sort of POCs, some directly, some indirectly, and the end result is sort of, building architecture like that in quite a few of them. Generally speaking, the infrastructure is too static to really be, and it's fragile for the real world. This is something that we have to sort of, start really addressing, because with the static models that we have, the sort of federation, the technologies that we have at our disposal right now, we can't really sort of, get to a complete dynamic model that would be able to sustain itself for 50 years from now. The device identity context, that's, again, there are products, there are technologies that we do that helps us with that, but it's certainly not ubiquitous, and it's not everywhere. That we have to do a lot more work in that space. We really need to start sort of looking at authorizations and access at much higher level, at sort of a risk-based policy type of things. We can put in the business risk as part of the policy and turn that into what sort of, at the bits level is being done on whether sort of this device has access to make that call over the wire or not. I mean, you can, if you look at sort of the firewall technologies, this is essentially where we are as like late sort of, 90s, where we sort of, said this IP address, this port number can talk to this IP address, this port number. That type of sort of access control is what we're using for the most part in the enterprise today. What we really need to get to is, this is the application, this is the operation that we want to do. It doesn't matter whether this is the identity, whether that's the sort of, the policy. You want to sort of take advantage of the context, take advantage of the higher level sort of notions, and then turn it into a sort of an actual decision on the authorization and access control. Everybody's been talking about dynamic and continuous identity. This is, again, sort of that context rolling into it, and it's always changing. Just because the temperature sensor in the room was something that I could trust yesterday doesn't mean that I can do that today. It doesn't matter whether they have the certificate or not. There's a whole bunch more that goes into that sort of, trustworthy part of it. We have a whole bunch of standards. We have everybody making new standard organizations in the IoT space. Seems like every other day I see a new announcement of consortium, but we really need to figure out what we're going to do with this. If it's disjointed and there's a piece of it that's being done at IETF and a piece of it is done somewhere else and a piece of it done somewhere else, how are we going to bring it together to have a whole complete system? And that's something that I haven't really seen much progress on. And then the life cycle, right? The whole provisioning, deprovisioning. How do I sort of bolt on a new part into this big machinery without sort of, disabling it, without being sort of, going through a life cycle of key management and doing all the fragile things that we do today with a lot of the PKI stuff. And then last is sort of learning a lot from the security part of the world. This is not just an identity. Identity and security really need to sort of go hand in hand. It's been really eye-opening for me now that I work in a security group, how similar the problems are and how connected we are, but how far apart the security professionals and identity professionals are. We sort of completely miss each other's point. We can't even communicate on basic stuff. And that's really got to change if we want to sort of solve some of these problems. And the problems are, again, a lot of the things that we've done generally and traditionally has been around how do I sort of do the initial sort of protection, the before sort of model, right? But really we haven't sort of spent too much time over the last couple of years. Certainly sort of, things have gotten better. What happens when there is an attack and there's a breach happening? What happens after it? And all of those things really need to roll into the identity and into our culture, which we've been, okay, I get you sort of this authentication, I get you a token, that's good enough. What about the rest of it, right? So that's a piece that really needs to come into play. That's it. That was my spiel. Questions? Nobody? Oh.
So,
Mm-hmm.
Identity versus identifier. And for example, again, this Luminar example. So what, for example, the process on how you install those, or how they are typically installed in a commercial building like this is you build them up there, they have some identifiers at the beginning, like a network address if it's using a legacy protocol like DAI. But then someone comes along and commissioner, and he actually goes to the room and figures out on like which ones should I group, and those
Mm-hmm.
should be tied to a specific notion that is visible to some human. Like you would give whatever the name of this room is, you would assign all these lights, these luminaires to a specific room. And I think that's where the distinction between identifier and then this broader notion of identity comes along that you have been elaborated.
Right.
And I think in general, I think we need both. So we need the sort of these stable identifiers because ultimately under the hood, so the user then says, some user then configures these lights to work like the way they are and defines different scenes and so on. But then under the hood, some controller, some message that needs to go to a specific light and then now turn it on to volume whatever, which is not visible, but to the user, but there's some metadata.
Right.
Call like the location between the metadata or whatever. Which is a very difficult concept in terms of like how you determine the trustworthiness of a thermostat or the data you get to. What is it? Maybe the sensor has been hacked, or maybe there's someone just putting even the hand next to it.
Mm-hmm. Right. So you're absolutely right. It's all of above. I think you do need all of those things. You absolutely need sort of the trust anchor so that you can deal with upgrades and sort of firmware things and everything else, right? So it's all of above. But that provisioning part of it is often sort of forgotten, or we don't talk about it and we don't really focus around building the system, which becomes the operator's problem later on. And generally, I've seen that we've seen it in sort of, look at sort of even in the user identity, we really failed at that provisioning problem multiple times. Hopefully Skim will solve it, but sort of, there's a lot of pieces that we don't really look at the operational parts of it.
But it's also a difficult aspect because each use case is slightly different. Each community is very different. And I mentioned this Luminar example because I'm participating in a group on a project on that topic. In the way how the business works with Luminar, the commercial feelings is very different from how it works in for example, in the home.
Mm-hmm.
Or how, let's say, the turbines that you mentioned, the jet engine, how those would work. Very different businesses. If you want to standardize something on what you actually need to provision, on two provisions, or what the security requirements are, what the legacy,
right.
And how long the devices would last, etc. It's very different.
I totally agree, but again, sort of, authentication is very different for different use cases, and we managed to actually get a pretty good story around that. How do we sort of do different levels of authentication for different levels of risk and different levels of solutions, right? So we should be able to do better than that. I agree, it's a really difficult problem. Same thing with the authorization, but we have to do better.
I think we need to wrap up.
All right.